Hi guys, welcome to lesson 2. Go ahead and get out notebook, paper, and pencils, or whatever you need to take notes. Today we're doing solving systems with elimination and substitution. You hopefully have seen this in Algebra 2, but we're going to go over it today. So last class we did solving algebraically, or graphing, and today we're going to solve systems algebraically with two main methods, substitution and elimination. So we're still working on this goal of solving systems of linear equations. The first system is the first method is kind of similar to elimination or substitution. I know that y equals 6x minus 13 and y equals x plus 32. That is my system. So this is equation 1 and equation 2. So they make up a system. I know that y is a fair trade for x plus 32. So I'm going to put this into that spot for y. So now I can actually solve this for x because I have all of the same variables. I just have x's. So I can go ahead and combine like terms. And I'll get 45 equals 5x. And then if I divide both sides by 5, I get x equals 9. However, I'm not done because I still need my y value. So I have x, which is great, but I need my y equals x plus 32. I'm going to put 9 where I see x. So now I have my x and the y values to be y comma 41. I want you guys to pause the screen in a second. Go ahead and solve this one. Everywhere we see, I know that y is a fair trade for 5x minus 9. So go ahead and pause the screen and try to substitute 5x minus 9 where you see y, and then go ahead and solve. Once I substitute, I get something that looks like this. I'll just go ahead and add 9 to both sides. And I'm still just isolating for x. So once I get x equals 8, I'm not done because I still need to put 8 where I see an x to solve for y. And then if I were to write that as a point, I'd have x comma 31. So you're taking these notes, you can write the title, the topic at the top, or page number, whichever one's easiest for you. Okay, we're going to continue working with substitution. So when you substitute, you're basically saying, like making fair trades and saying this value can substitute for this value, or this number can substitute for this value. So to do that, we need to isolate one variable in an equation and then substitute it into the other. So I'm saying that x equals 2, and that's a fair trade. So I'm going to rewrite this equation, instead of an x, I'm going to put a 2 because we decided that that was a fair trade. And now I can solve for my y because I only have the y variable. This is asking us to say that 2y is a fair trade for x. So I would then put wherever I see an x, I'd put a 2y. I can combine those. And then something else we could be talking about is here y was 1 and x was 2, so it'd be 2 comma 1. Here I know my y, but I don't know my x yet. But now I can solve for my y, or my x using my y. So I would have 1, 2 comma 1 again. So this last one's asking us where we see x to put this. So notice how on all these I have a variable value by itself, so I basically know like the exchange rate is what I like to call it. So wherever I see an x, I'm going to put a 2y minus 1. So this answer is not a nice answer, but we can still do it. And then wherever I see a y, I would put 7/4. So this is not a nice one, and you guys should not have one this hard on your in your work, but you get 10/4, comma 7/4. So when I look at these, I'm going to ask myself, do I have the exchange rate for one of the variables? I have the exchange rate for x. I know it's worth 2y minus 14. So I'm going to put that everywhere I see an x. And now I have an equation with all y's, and I can just go ahead and solve that. And then I'm just doing my basic steps to solving a linear equation. So I know that y equals 5, but I'm not done because I don't have the value for x yet. So I know x equals 3 times 5, because that's the value for y, minus 14. So I have 5 and 1 are my y and x value. So really good, this example, I do not have the exchange rate for a variable. But when I look at it, it is going to be easiest to get this x by itself because it doesn't have any coefficients in front of it. So if I have x minus 2y I can add 2y to both sides. So now this is my equation 1, this is my equation 2. I'm going to go ahead and put this into that x equation. So everywhere I see an x, oh no. So I put that into there. And now I can just solve this. And I know that y equals -2. So now that I know my y, I can plug it into the equation x equals 2 times my y value of -2 plus 9. So I have x is 5 and y is -2. Okay, next we're going to talk about solving with elimination. So we want to create our y's on top of our y's like we have here. Oops. Our x on top of our x's and our constants on top of our constants. And we want them to be so that when you add down, it adds to 0. So you want them to be the same number, but one positive, one negative. So if I look what I have, I already have a situation where my x's would be eliminated if I added them. So I'm going to add down each 2y plus 5y is 7y, 7x minus 7x, or plus -7x. And these add to 7. So I have 7y equals 7. In other words, y equals 1. And then once I have that, I can go ahead and plug that back into the equation to solve for the other variable that got eliminated. So we have our solution of -1, 1. So we're going to keep practicing with this, but the gist of it is you want coefficients that are the opposite and would add to 0. Once you have that, you do that, which eliminates a variable, and then you solve for the other one. Okay, we're going to go ahead and start over here with this one. I think that you guys see my x's on top of x's, my y's on top of y's, my constants on top of constants. I want to see, do I have a pair of coefficients that add down to 0? I do here with the 3, so I'm going to pause the screen. Go ahead and try to solve for y. So simply pause the screen, add down your y's, or your y's will be eliminated, so then you'll solve for x. So pause the screen, add each column down, and then solve for x. So you end up with 0y. This is what we should have gotten for x. I'm not done yet. I need to plug that x value in to one of those equations to solve for y. And now I'm just solving for y. So I get the points -2, -3. If I look at what's happening over here, I do not have, none of these add to 0. None of them are equal opposites. So what I can do is multiply all of this by a -1 to make it become, and this one just stays as it is, but now if I were to add down, my y's would be eliminated. So I can go ahead and do that. I get -3x equals 15. So I know that x equals 5. I can plug that in over here. I feel like I made a mistake. Oh, my mistake, you guys, was back here. This should have been a -5. So I'm plugging in a -5, which makes this a +15. +15. Makes this 25 divided by 5 is 5. So for this I have the answer of 5, of -5 comma +5. Okay, so for this problem we have the same idea. It asks us to use elimination. We have x's on top of x's, y's on top of y's, the contents on top of each other. But I see that none of these add down to 0, so I need to make equal opposites. I could make my x's add to 0s or my y's add to 0. I'm going to make my x's 3 and 2 both go into 6. So I'm going to go ahead and make one of them a +6. And one of them a -6. So go ahead and pause your screen, take the time to solve this. You end up with 13y equals -13. Y equals 1. Then we plug that back into one of the original equations. We end up with -1, sorry, not +1. That's where we made a mistake. So my solution is -1, -1. Okay, I want you guys to go ahead and try to solve this one on your own. I'm going to give you a hint that I would multiply, nothing adds to 0, so I'd multiply the whole first row. I'd use my 15, 5 and 3 both go into 15. So I'd make this a +15 and keep the top as a -15. go ahead and take the time to solve this on your own. I'll put up the key for it in a second. We end up with an x equals 8 and a y equals -5, so we'd write that as our point 8, -5. Okay, last class we talked about graphically how we know if we have one, none, or infinite many solutions. Today we're going to talk about at the bottom how you know this algebraically when you do it. If you get a single solution, then it is a one answer. If you get a false statement, and no answer. If you get a true statement, it's infinite many answers. So we're going to take a second to do problems like that. Okay, system A. I want you guys to take a second to try to solve it on your own with elimination. I'm going to do the work for it up here. We do not have numbers that naturally add to 0. So I'm going to go ahead and we'll just multiply the second row by a -1 because that will get my y's are already the same. Then I add down, I get 1x equals 7. That was easy enough, beautiful. And then I can just plug that in for an x and solve for y. So I get 5, 2. I got a single answer when I solved, so this has one unique solution. Oh, 7, 2, not 5, 2. And actually I made a mistake. That divided by that would be negative, which would make that negative. This second one, if I look at this, I can add down now, and my y's would eliminate, and my x's would eliminate. So I get 0x plus 0y equals 0, or 0 equals 0. This is a true. So this means it has infinitely many solutions. So if I get a true statement, it means infinitely many solutions. Let's go ahead and try this last one. I do not have opposites. I'm going to go ahead and multiply the bottom one by -1. Then I can add down. +1 equals 0x plus 0y. So 0 equals +1. That's not true. So if it's false, it has no solution. So this is skill 2.